Okay, hey, hi everyone. Today we are going to discuss about electrolysis, O-level chemistry. This is class number 12, and this is the first part of our electrolysis. So, first of all, let's learn about what is electrolysis. Okay, so electrolysis actually means, look, the definition has been given here. Electro means electricity or using electrons, and lysis means separation of the charged particles. Okay, so then what happens during so what do you actually do during electrolysis is, for example, okay, for example, you have sodium and chlorine combined together. All right, why? Because sodium has a positive charge and chlorine has a negative charge, for which they would attract each other by means of strong electrostatic force of attraction. All right, okay. Next, what would happen is that now, using electrolysis, you can separate the sodium ion and the chloride ions. Here they were together, and here they are now separated. The ions are now separated. And if you carry out the separation of ions using electricity or using electrons, then we call it electrolysis. Okay. So what happens during electrolysis? The ions, look, ions of an ionic compounds are separated and neutralized. This point is very important. This part of the slide, the whole slide, the defining electrolysis, this is very important. Look what happens. So the ionic compounds are separated and they are neutralized. Okay, so separated and neutralized, these are the two key points. And so for the electrolysis to occur, you must supply a medium where the ions can move, isn't it? Because if these ions has to get separated, then they must move, isn't it? They must move apart, away from each other. The ions must move. Okay, so now tell me, in which medium or in which state can a particle move freely about? It is actually liquid state or gaseous state, isn't it? So we will not be using any gaseous state here, because that's so much expensive, and it's so much difficult to convert ionic solids to gases. So we will be using liquid state. So liquid state, there can be two types. Okay, so we can have two types of liquid state. One is the molten state or the aqueous state. Now what is the meaning of molten state? Molten state actually means, for example, the ionic solid was A and it is directly heated to form ionic solid A liquid. Okay, that means here the solid is directly heated and then converted to liquid. It's like melting. Molten actually also means melting. Okay, like when you are heating ice directly turns into water, isn't it? We can call water as a molten ice. Okay, so we can use either the molten state or the aqueous state. Aqueous state actually means dissolved in water. It's like, for example, when you are mixing salt with water, that is called the aqueous state, or we call it aqueous salt, because you have dissolved the salt in water. Okay, so before going into further details of electrolysis, we need to know about some terms. For example, first of all, anion. Okay, anion. You can visualize or symbolize the term anion in the following way. That, let me zoom it. Okay, so here you have A. Okay, so here you have A. A stands for A, N stands for negative, and ion means ion. So a negative ion. All right, look, so anion, you can remember it in this manner, that anion means a negative ion. Okay, and if you don't want to remember this, then you can also keep in mind the cation. Like, I imagine it in this way. Look, let me tell you, CATION. So just forget the CA. Okay, it's like TION. Now imagine the T as a plus. Okay, this T can be imagined as a plus. Okay, CATION. So forget the CA, you are left with TION. This T looks like a plus, so TION means actually plus ION, which means the positive ion. So cation means a positive ion. Okay, okay, all right. So cation means a positive ion. Okay, since I have started with anion, so I'm continuing through the anion. So if anion means a negative ion, so anion means a negative ion, so cation must be a positive ion. Okay, and since anion is negative and anion goes to anode, so anode must be positive, because only positive can attract a negative. Okay, and again anion is negative, so cation is positive. Since cation is positive, so for attraction or for causing the attraction, the cathode must be negative. Okay, in this way we can remember the anion, cation, the anode, and the cathode. Okay, so here we have two more pictures, but no description is given, but let me describe the pictures for you. So just remember that during electrolysis, what actually happens. So during electrolysis, the ions of an ionic compounds are separated and neutralized. Okay, so these two pictures actually tells you that how the ions are separated and in what way they are neutralized. Okay, first of all. Okay, so first of all, this picture is the picture of an oil rig where oil is extracted. All right, so it's oil rig, and oil rig in this case would stand for oxidation is loss of electron and reduction is gain of electron. I will repeat, oxidation. Okay, let me change the color. Oxidation is loss of electron and reduction is gain of electron. Okay, so in our electrolysis we have two ions. One of them is the cation, which is the positive ion, and anion, which is the negative ion. Now look, this cat presented here, this cat is red, isn't it? So you can tell it that it's a red cat. So red stands for the reduction and cat stands for the cation. So reduction of cation occurs, and reduction occurs where? At the cathode also, because cation goes to cathode. So reduction of cation means this is the red cat. Okay, just remember the picture of this red cat. Okay, so red cat means reduction of cation. So the opposite is the oxidation of the anion, and reduction means loss of electron once again, and oxidation means reduction means gain of electron, and oxidation means loss of electron. Okay, now let's go to the circuit setup of electrolysis. Okay, so look, so here we have an unlabeled diagram, but I will label it for you. You must write it in your copy. Look, so an electrolysis setup has got a positive rod, and it has got a negative rod, then it has got a it has got a positive ion, it has got a negative ion. All right, okay, so it has got a positive ion, it has got a negative ion, and it has got a solution in which both the positive and the negative ions are staying. Okay, so let's start from anion. Anion means a negative ion. All right, so this B around here, the B, it must be the anion. So B is the anion, the negative, so it should go to the positive rod. So it should go to the positive rod. So this positive rod is the anode. All right. Okay, so B is the anion, so A is the cation. So this A, the positive ion, the cation, would go to the negative electrode. All right. So this negative electrode is the cathode. Okay, cathode. And the solution in which the both A and B is remaining is known as the electrolyte. So now you have the basic ideas of the circuit setup. So look, an important thing to remember, that the rod which is positive is connected to the positive side of the battery, and the rod which is negative is connected to the negative side of the battery. Okay, all right. Now let's go to the discharge equations. That means discharging actually means making neutral or removing the charges. Okay, okay, so the discharge equation, look, this is very important, this part, that the number of electrons lost or gained is equals to total charge on the ions. This means, for example, like so here is a space I've created. For example, if we were talking about sodium ions, so how many charges, what is the charge here? The charge is 1, isn't it? The charge is +1. So sodium will deal with only 1 electron. Okay, what is the charge on calcium ion? The charge on calcium ion is +2. So calcium will deal with 2 electrons. Okay, again, for example, phosphorus, it's 3 minus. So what is the charge? 3 minus. So the phosphorus ion will deal with 3 electrons. Okay, so this again reveals that a certain ion will deal with equal number of electrons as that of its charge. That means the amount of charge it has, it will deal with the same number of electrons, 3 minus, so charge is 3, so it deals with 3 electrons. Alright, keep this in mind. Okay, so that's what the information said here, that the number of electrons lost or gained must be equal to total number of charge on the ions. Oh, one thing more, like for example, you are talking about 2 Cl minus. I'm bored of Cl minus. I'm talking about 2O2 minus, alright? So, what is the total charge here? A single oxygen has got a charge of 2. So, there are 2 oxide ions. So, the total charge will be multiplied and the total charge is 4 minus. Okay. So, these 2 oxide ions, so the 2 oxide ions will deal with how many electrons? 4 electrons. Or you can think it simply that a single oxide has got a charge of 2, so it deals with 2 electrons. So it deals with 2 electrons. So 2 oxygen, so 2 oxygen will deal with 4 electrons. Okay. So again, what I'm repeating is that the total number of electrons lost or gained, the total number of electrons which are lost or gained has to be equal to the total charge on the ions. Alright. Okay. Now, what is the fact? So, you know that red cat, that means reduction of cations, and reduction means gain of electrons, and reduction of cations, so oxidation of anions, and oxidation means loss of electrons. Okay. And anion means what, you remember? Anion means a negative, anion means a negative ion. Okay, so let's look at some example discharge reactions. For example, I am asking you write an equation for the discharge or neutralization of phosphorus 3 minus. Okay, so what is this? So this is a negative ion or anion. Okay, so cations are reduced, or reduction of cations, red cat. Okay, so it should be oxidation of anions, and oxidation means what? So the anion should be oxidized, since there is reduction of cations, so anion has to be oxidized, which means loss of electron. Okay, now to predict the loss, that how many electrons will be lost, you have to look at its charge. So what is the charge? Its charge is 3 or 3 minus. So it will lose 3 electrons. Minus 3 electrons, this will give P. Okay. So look, this minus represents here the loss of 3 electrons. So why 3 again? Because it has a charge of 3 here. Okay, and the number of electrons lost or gained will be equal to the charge. Just remember that. Okay, now let's talk about silicon 4+. Okay, so 4+, so it's a plus. Okay, remember the plus ion means a cation. Okay, so it's a cation. Okay, so red cat means reduction of cations, and reduction means gain of electron. So how many electrons lost or gained? It will be equal to the charge. All right. Okay, so here the charge is 4, so it will gain 4 electrons, since it has to be the reduction of cations to obtain a neutral silicon. Okay. Okay, so that's what is for the reduction of cations and oxidation of anions. Okay, and one important thing is that, okay, this theme is also very important. Ions that contain multiple atoms, like you can talk about sulfate, you can talk about phosphate, you can talk about carbonate, etc., etc. Ions that contain multiple atoms are not neutralized, but only hydroxide is the exception. Okay, so there are more examples, like you can talk about ammonium, which are not neutralized because it contains multiple atoms. Okay, okay, so you can see that this slide is very much important. I would ask you to revise this whole slide, to memorize the whole slide. First of all, the number of electrons lost or gained must be equal to the total charge, and red cat, that means the reduction of cations, that means the opposite, the oxidation of anions. And you must remember the oil rig. Oil rig means oxidation is loss of electrons, oxidation is loss of electrons, and reduction is gain of electrons. So when you are writing electrolysis equations, I would prefer you as a beginner to write the memes, or to remember the mnemonics by just writing in one side of a paper and then carrying out the discharge equations. Okay, okay, now let's go to the discharge priorities. What do you mean by discharge priority? For example, a solution contains calcium ion, it contains hydrogen ion, it contains sodium ion. Okay, then it also contains, for example, chloride ion, hydroxide ion, or sulfate ion. Okay, so it contains, a solution may contain many positive ions or many negative ions. So when many positive ions are present, not all of them will be neutralized or discharged, only any one of them will be neutralized. It may be sodium, it may be hydrogen, or it may be calcium. Same goes for the negative ions. When many negative ions are present, only one of them will be neutralized or discharged. It may be chloride, it may be chloride, it may be hydroxide, or it may be sulfate. Okay, so how will we understand that which ion will get neutralized and which ion will remain as it is? So here the rule is given. For molten, I hope you can see it. Okay, so for molten or aqueous solution, the less reactive positive metal ions are neutralized by reduction. Okay, cation, you know, cation, the red cat, so they will get reduced, that means gain electrons. So in this case, the ion or the metal which is less reactive will be reduced and will get neutralized. Okay, and how will you then get to know the reactivity of the ions? You will get to know the reactivity of the ions from the reactivity series or the group trends, which we will look at shortly. So we have reactivity series and group trends. So down the reactivity series, the reactivity of metals decrease, and down the group of metals, the reactivity of metals increase. Okay, just remember that the reactivity series is nothing of the periodic table. The reactivity series has nothing to do with the periodic table, so don't mix up between these two. Okay, just remember them individually or separately. That reactivity series is this, and this is the group trend. Okay, so look, um, if you are a Bangla speaking person, then you will get to understand, especially my O-level students who are watching this video will get to understand this, that to remember the reactivity series you can use the mnemonic কে না কে মগবাজারে এলো যেন ফিরে সুমনকে পাবে হায় কাপুরুষ হাজি আজ পিটাবে আমায়. Okay, so this is a funny mnemonic that you may use to remember the reactivity series. And I would tell you that you prepare your own mnemonic to remember the groups, or during an exam time you will be given the periodic table. Okay, so what happens is that when you are going down the group or down the reactivity series, the reactivity is decreasing. When you are going down the reactivity series, the reactivity is decreasing, but when you are going down the group, the reactivity is increasing. Okay, and in case of non-metals, we don't have any such reactivity series. In case of non-metals, we don't have, we just have groups. Okay, so you know, metals and non-metals are opposite in nature, so the trend would also be opposite. That means if down the group the reactivity of metals increase, then down the group the reactivity of non-metals would decrease, but the rule remains the same. That means the less reactive ones gets discharged. Okay, or lower reactive negative ion gets neutralized. Okay, let me give you an example. All right. Okay, for example, group 7 is fluorine, chlorine, bromine, iodine. I'm not writing astatine. For example, a solution contains fluoride and chloride. Okay, so down the group the reactivity would decrease. That means chlorine is less reactive than fluorine. Okay, so chlorine is less reactive. So what would happen is that if fluorine and chlorine is present, then chlorine will get neutralized and fluorine will remain as it is, because chlorine is less reactive. Okay, but here is one more thing to go. That means the concentration of the solution also affects the neutralization or discharging of the negative ions, especially if the solution is aqueous. Okay, so aqueous solution, in aqueous solution what happens is that, just remember that when you are dissolving anything in water, the water molecule breaks down into hydrogen and hydroxide ions, as well as the salt that you are dissolving also breaks down into respective ions. Let me give an example. For example, you are dissolving calcium nitrate in water. Okay, so what will happen is that calcium nitrate will get dissolved into calcium ions and nitrate ions, two nitrate ions. All right, because there were two nitrates. At the same time the water molecule will also get broken down into hydrogen ion and hydroxide ion. Okay, this is always the case, that if anything is dissolved in water, water molecule also breaks down to give hydrogen ion and hydroxide ion. So any aqueous solution contains hydroxide ion. Okay, now the thing is that if the solution is dilute, first of all, if the solution is dilute means the concentration of the salt or the amount of salt in the solution, is low. Okay, amount of salt in the solution is very low, which means that okay, the concentration does not affect the discharge of positive charge, it only affects the discharge of negative charge. Okay, so if the concentration of the salt is very low, then the negative ion from the salt, or the amount of negative ion from the salt, also has a lower concentration. Okay, all right. But if for example, I'm telling you something, you are dissolving very small amount of salt, that the food salt, or what you call the testing salt, is dissolved in water, then you get Na plus and you get Cl minus. At the same time, water molecule will also get broken down into H plus and OH minus. Okay, now if you say that the solution is dilute, that means there is lot of water but small amount of salt, small amount of this salt, so you will get small amount of this ion but a large amount of OH ion. So in this dilute solution, what you will have is that hydroxide ion, the concentration or the amount of hydroxide ion will be much more greater than the concentration or the amount of chloride ions. Okay, and the rule is that the negative ion in aqueous solution which is present in greater amount gets neutralized or discharged. So in this case, in case of dilute solution, since there are lot of hydroxide ion in the solution from water and a small amount of chloride ions from small amount of salt, so in case of dilute solutions, the hydroxide ion is going to get neutralized. Okay, now what would happen in case of concentrated solutions? Okay, in case of concentrated solutions, concentrated means you have dissolved a lot of salt in water. That means the solution contains a lot of salt. That means I'm just ignoring the positive ion. That means the solution contains a lot of chloride ion, and in comparison, from water you will get hydroxide ion as the negative ion, but the amount of this ion will be much less than the amount of this chloride ion, because you have made the solution concentrated, isn't it? So what happens is that in concentrated cases, what you have is that the amount of OH, so the amount of OH is much less than the amount of Cl, isn't it? So in concentrated cases, the hydroxide ion has got a comparatively lower concentration than Cl minus. So in concentrated cases, Cl minus is going to get discharged. Okay, so that is the case. Now what you have to do is that you have to memorize the discharge equation of hydroxide ion. This is very important. You know that's something that has to be done or must be done, like you must drink water every day, or you must go to toilet every day. Not twilight, it's toilet. You must go to toilet or washroom every day. I don't know why I can't pronounce the term toilet properly. Okay, so you have to memorize this. The hydroxide, this is a negative ion, isn't it? So negative ion is anion. So red cat, reduction of cations, oxidation of anions. Oxidation of anion means they will lose electron, isn't it? Isn't it what they're getting? They're losing electron, isn't it? Let me see how they are losing their electrons. Look, here, this side, we have 4 hydroxide ions, okay, and we have a minus sign, which means something is being lost or taken out. What is being taken out? 4 electrons. Why 4 electrons? Because there are in total 4 negative charges, okay. So one hydroxide has 1 negative charge, so 4 hydroxide will have 4 negative charges. So 4 electrons are taken out to form this, okay. So this equation also expresses oxidation, because there is a minus that tells you that electrons are being lost. There is a minus, okay. And secondly, like, okay, this side has got no presence of electrons, but when the reaction has gone from the reactant side to the product side, look, there are electrons. So where does this electron come from? Obviously from these hydroxide ions, okay. So from the hydroxide ions the electrons have come out. That's why you are able to find electrons in the product side. That means this again also means the hydroxide ions are losing their electrons, okay. So how we will now remember this hydroxide discharge? Let me tell you. Okay, so write hydroxide 4 times. OH, 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 OH. Okay, now try to form as many as water as you can. Okay, so these two O and H would form a water. These two this OH and this H would form a water. This OH and H would form a water. So we can form 2 water molecules over here. So 2 water molecules. And now we are left with 2 oxygen atoms. So these would combine together to form an O2. Okay, and the 4 electrons, 4 negative charge, write them as 4 E minus. Okay, this is how you can remember the discharge of hydroxide ions. So first try to form as many as water as you can, then combine the rest of the oxygen, then combine the negative charges. Okay, that's how it works. Okay, now let me tell you the and there is one more important thing to learn, that in case of negative charges, look, already I have told this at the first, but again I am going to tell you. Look, ions that contains multiple atoms are not neutralized except hydroxide, and we have just seen it few moments ago. And again, look, the sulfate, nitrate, carbonate, phosphate, ammonium, etc., all these ions contain multiple atoms, right? So for example, ammonium has the formula of NH4, so it has got many atoms. Okay, so these ions which contain multiple atoms except hydroxide are never discharged. Okay, we should remember this. Okay, can you guess the discharge equation of fluoride ion? Okay, so this is negative ion, and we have the meaning of red cat. Red cat means the reduction of cathode, that means the reduction of positive charge. So this is a negative charge, so it should be oxidized. Oxidized means loss of electrons. Okay, now how many electrons will it lose? It depends on the charge. So it has got 1 charge, so it will lose 1 electron to become F. Okay, just think it in this way. Let me tell you again. So F minus, it's a negative charge. So negative charge is anion, and anions are oxidized. Oxidation means loss of electrons. So how many electrons will be lost? It depends on the charge. If charge is 1, that means 1 minus, so it will lose 1 electron and will convert it itself into F. Okay, you know that all halogens has got the formula of they are all diatomic, like F2 Cl2 Br2. Okay, all right. Oops, sorry. So F minus, since it has got one negative charge, so it will lose one electron, because the number of electron lost or gained depends on the charge. It will form F. So F minus minus 1 electron, this would form F. And if we combine these two equations together, write it as F2. So total 1 plus 1, 2 electrons lost, and total F minus plus F minus, this will give 2 F minus. Okay, now take some time to write a discharge equation for oxygen. Okay, just pause the video and try writing it by yourself, and remember you have to form O2. All right, welcome back. Okay, so this is a negative charge, so anions are oxidized. Oxidation means loss of electrons. So how many electrons will it lose depends on its charge. So its charge is 2, so it will lose 2 electrons. Okay, it will lose 2 electrons to form O. So sorry, so it will lose 2 electrons to form an O. So here we have O2, and we have 4 electrons, and we have 2 oxygen. Okay, now, okay, phosphorus has the charge of P3 minus. Now if I tell you to write a discharge equation of phosphorus and you have to form P4, can you write? I guess you can. Still, let me here is 4, so write it 4 times. So P3 minus, so negative charge means anion, and anion are oxidized. Oxidation means loss of electrons. So how many electrons will it lost depends on its charge. So its charge is 3 minus, so it will lose 3 electrons. So 3 minus, this gives P, and so phosphorus has to form P4, so we have to take 4 phosphorus here, so this must also multiply by 4, so this would become, so let me grab it, sorry, so okay, so we have to write here 12. Okay, so these are some examples of discharge, like okay, if I tell you to carry out the discharge equation of, for example, magnesium. Okay, so magnesium has got a charge of +2, so it's a positive charge, so cation, and red means reduction, means gain of electrons, so it should gain electrons. And how many electrons? Number of electrons lost or gained is equal to charge, so its charge is +2, so it would gain 2 electrons to form the neutral magnesium. Okay, so guys, so that's all for the class lecture of electrolysis part 1. If you do have any problem, please mention it in the comment section, and also mention your email ID so that I can send you the lecture sheet. And in the next class after the next class of electrolysis, I will give you the worksheet of electrolysis, and we will be discussing the problems in any one of the lecture videos. Okay, and before that, let me tell you something, that when I will be giving you the worksheet, please make sure that you are informing your problems in the comment section, so that I can make the video of the whole problematic parts from the lecture sheet. Okay, that's all for today. Thank you everyone.